Hello everyone, welcome to today's session. In today's session, we are going to learn how refraction is taking place through a glass prism and the concept of angle of deviation. In the previous sessions, we have learned how the refraction is taking place through a glass slab and how to draw the ray diagrams and the rules used for constructing ray diagram, etc. If you haven't watched the video, please watch the backup videos and learn how the refraction is taking place through a glass prism. Here in this case, refraction through a glass prism, the rules remain same and the medium remains same, that is glass, but only the shape of the body through which light rays are passing is different, that is a glass prism. Let us see what is a glass prism. What is the shape of this glass prism? A glass prism is normally made up of glass. Now let us try to draw a 3D figure for glass prism. Glass prism, it is made up of glass. It is bound by two triangular surfaces and three rectangular surfaces. Let us see. Yes, A, B, C, A dash, B dash, C dash. So this is the 3D figure for a glass prism. So a glass prism is made up of glass and it is bounded by two triangular surfaces. What are the triangular surfaces? A, B, C. As you can see on the diagram, A dash, B dash, C dash. So these are the two triangular surfaces. And what are the rectangular surfaces? As you can see, A, B, B dash, A dash, one rectangular surface, another one, A, C, C dash, A dash, another second rectangular surface, and the third one is B, C, C dash, B dash. So these are the three. It is bound by three rectangular surfaces and two triangular surfaces. Alright? Yes. But when you show a prism in a ray diagrams, a prism is shown only by its principal section. So I can show the principal section of the prism here. Only the principal section A, B, C. Only the front portion is shown there. This is 3D figure. This is 2D. Alright? Okay. So this is the principal section of a prism ABC. Now let us get acquainted with the profile of the glass prism. So here you can see this angle A. Angle A is known as angle of the prism. Angle of the prism. Alright? The prism we usually use here is known as regular prism. Okay, regular prism. Regular prism means it is an equilateral prism. So in an equilateral prism, all the angles are 60 degree each. 60, 60, 60 degree prism. We call it as regular prism or equilateral prism. Alright? Okay. So angle A is known as angle of the prism. And the surface on which prism is resting, you can see BC. This surface is known as base of the prism. Okay, base of the prism. Alright, okay, BC is the base of the prism, and the surface on which an incident ray falls, AB, and the emergent ray goes out, AC, are known as refracting surface. So I can write AB and AC. AB and AC are known as refracting surfaces. Refracting surfaces. Okay, so angle A is known as angle of the prism, BC is the base of the prism, AB and the AC are known as refracting surfaces of the prism. Alright, and this kind of prism we call it as regular prism, whose angles are 60, 60, 60 degree each. And this type of prism is also known as equilateral prism. Alright? Okay. Okay, we got introduced with a glass prism. Now let us study how refraction is taking place through a glass prism. For that, we will represent a glass prism by its principal section ABC. ABC is the principal section of a glass prism. As you can see, the refracting surfaces AB and AC are inclined to each other. In case of glass slab, the refracting surfaces were parallel to each other. Here, AB and AC, the refracting surfaces of a prism, are inclined to each other. Okay. Now an incident ray is falling, an incident ray PQ is falling on the surface, one of the refracting surface AB. Alright. Now let us draw a normal to the surface point of incidence. So I have drawn a normal to the point of incidence. Alright. Okay. Now we can see the ray of light PQ is falling on the surface AB and it is ready to enter into glass. So light rays is traveling from air to glass. As you know, it is made up of glass. Glass is a denser medium, and when a ray of light traveling from air to glass or rarer medium to denser medium, as you know, it bends towards the normal. So it slightly bends towards the normal. Alright. So QR is the refracted ray, QR being the refracted ray. Alright. Now the ray QR is incidenting on the point R on the surface AC. So QR, the refracted ray, striking the surface AC. Now it is ready to go out of the surface AC, or it is ready to emerge out. For that we have to draw a normal to the surface. Alright. A normal is drawn. Okay. Now the ray of light QR, the refracted ray of light QR is ready to emerge from denser medium to rarer medium. It is going to air. So what happens? What is our rule? So when a ray of light traveling from denser medium to rarer medium, it bends away from the normal. Bends away from the normal. RS. RS is known as the emergent ray. Of course, RS is also a refracted ray, but when we say it, we say that it is an emergent ray. RS is the emergent ray. So PQ is the incident ray, QR is the refracted ray, and RS is the emergent ray. Okay. So you can see that when a ray of light traveling through a glass prism, it is bending towards the base of the prism. You can see it is bending towards the base, slightly bending towards the base of the prism. So that is one of the important point that you have to remember when you are making or when you are studying the refraction through a glass prism. What is that important point? When a ray of light traveling through a glass prism, it always bends towards the normal. It is bends towards the base of the prism. Bends towards the base of the prism. Very important point. Alright? Okay. Now, see, the ray PQ is incidenting on the surface AB. If there was no glass prism, what would have happened? It would have traveled in a straight line. It would have traveled in a straight line. Alright? Okay. Now you can see that the emergent ray, you compare emergent ray with respect to the incident ray. So this is the angle of incidence, as you know, the angle between incident ray and the normal. And the angle between the incident ray, normal and the emergent ray is known as angle of emergence. And the angle between the normal and the refracted ray is known as angle of refraction. Alright, all the angles we have marked. Now, you just compare the incident ray PQ and the emergent ray RS. You can see that the emergent ray has deviated from its original path of, that is, direction of PQ. So the PQ would have traveled along a straight line path. Alright, PQ along PT if there was no glass prism. Okay. Now, how do you find out the angle through which the emergent ray has shifted from its original path? You can see that the emergent ray has, of course, obviously you can see emergent ray has turned through certain angle and it is deviated from its original path of the incident ray. How do you find it out? So take the help of the geometry. Now what do you do? Produce the incident ray forward. If there was no glass prism, the light ray, the incident ray would have traveled along a straight path along PT. And now where it will meet the emergent ray? How do you find out the meeting point of emergent ray? Do one thing, just produce the emergent ray backward. Okay. Now it is meeting at this point M. Alright, the emergent ray, when you are producing the emergent ray backward, it is meeting at the point M. Now you are getting an angle between, see, you are getting an angle between the incident ray produced forward and the emergent ray produced backward. This angle, I call it as angle of deviation. I call it as angle of deviation. Delta is known as, it is denoted by a letter, Greek alphabet, delta, and delta is known as angle of deviation. Angle of deviation. What is angle of deviation? As you can see, angle of deviation is the angle through which the emergent ray has shifted from its original path. Okay, so the angle of deviation is the angle between the incident ray produced forward and the emergent ray produced backward. All right, so I can write angle TMS, angle TMS, that is, this angle is known as delta, represented by a small letter delta, Greek alphabet, and it's known as angle of deviation. Okay, clear? So this is how the refraction is taking place through a glass prism, and you can calculate the angle of deviation. You produce the incident ray forward and produce the emergent ray backward. You simply get the angle of deviation, the angle through which the emergent ray has deviated from its original path. Okay, so this is all about refraction through a glass prism. Very simple. You can remember the refraction through a glass prism in a very simple method. So always remember the point: when a refraction is taking place, when a ray of light passes through a glass prism, it bends towards the base of the prism. Alright, very simple. See, always bending. See, a ray of light is incidenting on the face, in refracting face AB, bending towards the base of the prism, and again further bending towards the base of the prism. So this is how the refraction is taking place through a glass prism. So when you compare the refraction taking place through a glass slab and a glass prism, the medium remains same, the rules are same here. What difference do you find here? The refraction between the refraction through a glass prism and the refraction through a glass slab. In a glass prism, the refraction of light occurs at two inclined surfaces, as you can see, at two inclined surfaces AB and AC. So the emergent ray is not parallel to the incident ray. In case of refraction through a glass prism, the emergent ray is never parallel to, here I can say that RS is not parallel to PQ, the incident ray. Why? Because AB and AC, being the two refracting surfaces, are not parallel, they are being inclined. Okay. So on the other hand, in case of a glass slab, what do you find? PQRS. The refracting surfaces PQ and RS parallel to each other, and very simple, refraction is taking place. Again, see, you can see the incident ray and the incident ray ABCD. So AB and CD, emergent ray, are parallel to each other because the surfaces PQ and RS are parallel to each other. So this is the only difference between the refraction through a glass prism and the refraction through a glass slab. In glass slab, the refracting surfaces being parallel to each other. In case of glass prism, the refracting surfaces inclined, AB and AC being inclined to each other, and the incident ray and emergent ray are never parallel to each other. Always the refracted ray bends towards the base of the prism. So things are clear? Okay. Thank you very much.